Thank you for joining us. And before we take the exams, let us review this year's quiz questions. We have 20 questions in all, so let's jump right in. So the first question is asking us to consider the parametric equation x, y, and z, and then we have the plane which has equation of this, right? And then we want to verify which one is true, which of these is true. So the first thing that we just need to do is let's take them one by one. So first, the first one is saying that the line lies on the plane. So let's check if it is true. So for us to check if the line lies on the plane, then we want to check if it lies on the plane entirely, right? So let's pick the first point that we have. We have x is equal to 1 minus 2t. We have y is equal to 2 plus 5t. And then we have z is equal to minus 3t. So what we are going to do is I'm just going to substitute this into the plane and then we solve for t. So I'm going to have 1 minus 2t plus y. Now y is 2 plus 5t minus z is minus 3t, and this is equal to 8. So this is going to give us 2 minus 4t plus 2 plus 5t plus 3t is equal to 8. So this is going to give us t here, t here, t here. So this is going to give us 4t plus 4 is equal to 8. So now let's try and then find for t. So 4t will be equal to 8 minus 4, and t will be equal to 4t will be equal to 4. So here t will be equal to 1. Now we have only t to be equal to 1. So it means that this line here or this equation here intercepts the circle at only one point, right? It intercepts the circle at only one point where t is equal to 1. So we can see that here the equation here does not lie on the plane entirely. So we are going to say that this is not true. So this one is just out. So now let's look at B and C, right? Now B, we want to check if the line is parallel to the plane. So let's check if the line is parallel to the plane. So for us to check this, first we need to pick the directional vectors. The directional vectors are always the one with the t. So minus 2, 5, and minus 3 is going to be the directional vector. So the directional vector is going to be minus 2, 5, and minus 3. So this will be the directional vector. Now let's look for the normal vector. The normal vector is always taken from the plane, right? And they are the coefficient of the x, y, and the z. So the normal vector 2 is equal to 2, 2, 1, and minus 1. So for us to check if they are parallel to each other, we need to dot this and that. So that's basically what we just need to do. So let's do that. We are going to have d dot n to be equal to minus 2, 5, minus 3 dot 2, 1, and minus 1. So this is going to give us minus 4 plus 6 plus 3, right? So I multiply this by this by this, and this by that. So this is going to give us, I think this should be giving us 4. Is that right? Yes. Or it's supposed to be giving us 5. Okay, this one's supposed to be 5, so that it can give us 4. So we see that this is not equal to 0. So this one, it's not parallel to the plane, right? So the next thing that we need to do here is we need to check for perpendicular, right? So what we just need to do here is we are talking about a line and a plane. So a line is perpendicular to a plane if, let's say, D, which is the directional vector here, is parallel to N, meaning that we have something like this. This is what we are talking about here. It means that we have some D, which is equal to a scalar N, right? So that is how we can say that the function is perpendicular to the plane. So what we are going to do here is now looking at D, we want to look at any scalar that we can multiply to this to get this, right? So for us to get the first -2 here, we see that if we multiply this one by -1, we'll get this one. But multiply this one by -1 and -1, you are not going to get this one. So indeed, we don't have any scalar that we are going to use to multiply this to get this. So what we are going to say here is we are going to say that the line is not also perpendicular. So the best option that we need to choose here is D. That's the best option that we are going to choose from here. Now let's look at question 2. Question 2, which of the following is the unit normal to the surface, right? So this question is kind of like advanced question. You know, the question, the course that you are going to take next semester, but I think it's also in vectors, right? So what we are going to do here is we are going to find the gradient. So the gradient is basically the grad f, which is equal to you differentiate f partially with respect to x, this partially with respect to y, and this partially with respect to z. So that's what you are going to do. And what we just need to do here is we need to form our f. So here what we are going to do is we are going to write this one as this: x minus xy minus z squared is equal to 0. So when I move minus z to the power 2 to this side, I have this. Then I'm going to equate this one to big F, the F that I'm using here, but now the function is x, y, z. So that's what I'm going to get. So now I'm going to differentiate this with respect to x, y, and z, and see what we are going to get here. So grad of f will be equal to differentiate this with respect to x, and I'm going to have partially, I'm going to have y. Differentiate this one with respect to y, and I'm going to have x. Differentiate this with respect to z, and I'm going to have 2z, right? So that's basically what I'm doing here. Sorry, it's supposed to be minus, but there's minus in front there. Okay, so minus here. Then now what I just need to do is let's try and plug in the point, right? Let's do that. So we are going to have this one to be, the point is 1, 1 minus 1, 1, 1 minus 1. So I'm going to have 1, 1, and 2. So this is going to be my point. Now the question is asking us to find the unit normal, right? So the unit normal that we are finding here is basically, if we are having this one as the unit normal, the unit normal will be equal to the grad of f divided by the magnitude. So this one is basically like when we are finding unit vector, right? So the vector divided by its magnitude. So let's look for the magnitude of this. What are we going to get? Square root of 1 squared plus 1 squared plus 2 squared. So 1 plus 1 plus 4, and this is square root of 6. So this is going to give us something like this. Let me see. This is going to give us 1, 1, 2 divided by square root of 6. So let's check if we have 1, 1. Okay, so let me write this one in the direction form. So this was I plus j plus 2k divided by square root of 6. So all with positive, right? So we are going to pick C as the results here. So this is very simple also. If you know this formula here, you are good to go. Let's look at question 3. Now, which of the following is the angle between the surfaces? So these questions are basically, we need to be using the grad also here. So let's do that. First, let's assume that, let us move this function to this side, right? So that we are going to have x squared plus y squared minus z minus 3 is equal to 0. So I picked this equation here, but I just moved the z to this side, so it will be equal to 0. And let me name this one f of x, y, z. F of x, y, z, right? And then let me pick this one too and move the 9 to this side. So I'm going to have x squared plus y squared plus z squared z squared minus 9 is equal to 0. And let me name this one gen of xyz. So now what I just need to do is, I want to find the angle between the surfaces, right? So basically what I just need to do is I need to think of, like, if I'm using dot product, then a dot b is equal to magnitude of a, magnitude of b, cos of theta, right? But here, what we just need to do here is, here we are talking about surfaces. So we need to find the grad before we can talk about what we have here. So let's do that. What is grad of f? So grad of f is differentiate f with respect to x, f with respect to y, as we saw from earlier, and then f with respect to z. So let's do that. First, let's differentiate with respect to x. With this one, we are going to have 2x. Then with respect to y, we are going to have 2y. And with respect to z, we are going to have minus 1. Then let's go grad with respect to grad of g. With respect to x, we are going to have 2x, y is going to be 2y, and z is going to be 2z. So this is what we are going to get. We have the point here. This is the point. 2 minus 1, 2. 2 minus 1, 2. So let's do substitution for this and see what we are going to get from here. So this is going to give us something like this. Plug in 2, and this will be 4 minus 2. This is minus 1, so it's still minus 1. And then plug in the same thing. This will be 4 minus 2, and this will be 4. So this is what you are going to get for the function when you plug in 2 minus 1 and 2. So the next thing that we just need to do is, since we are finding the angle, then we need to, if we are using this, then maybe I can say that, okay, let this one to be equal to A, this one to be equal to B, so that I can talk of A dot B is equal to magnitude of A, magnitude of B, cos theta. So that cos theta here will be equal to A dot B divided by magnitude of A, magnitude of B, and then theta will be equal to cos inverse of everything that we are going to get from this. So let's look for A dot B, this times this, which is here. So let's do that. A dot B will be equal to, we are going to have this 4 minus 2 minus 1 dots 4 minus 2 and 4. So dot product will go direction by direction, right? So let's do that. This is going to be 16 plus 4 minus 4. So this is going to give us 16 for A dot B. Let's find magnitude of A. Magnitude of A is going to be 4 squared plus minus 2 squared plus minus 1 squared. So this is going to give us 16 plus 4 plus 1. And this is going to give us square root of 21. Now let's look for magnitude of B. So this is going to be square root of 4 squared plus minus 2 squared plus 4 squared. So this is going to give us 16 plus 4 plus another 16, what is going to be 36, and this one will be 6. So now let's do substitution. Theta is equal to cos inverse of A dot B is 16, which is from here, right? And the magnitude of A, magnitude of B, when I multiply this one by this, I'm going to have divided by 6, square root of 21. Let's check the answer. Okay, so they simplified it, and this is going to give us cos inverse of 8 divided by 3 square root of 21. So 2 goes here, 3 goes here, 8. So 8 divided by this. Okay, so we have it here, which is right here. So that's basically what we just need to do here before we get the results that we need from here. Now let's look at question 4. We have 20 questions. So which of the following shows the application of dot product? So remember, I will talk about A first, but remember, whenever we are talking about area of a triangle, we need to use the cross product. So this one, we are going to use the cross product, right? because we know that for us to find the area, we need to look for, let's say, A cross B. We find the magnitude, we divide by 2, then we get this one, right? Now we want to find the unit vector perpendicular to the two vectors too. We need to also use the cross product, right? So we find the cross product, and then what we are going to do is now we just find the unit vector. So that's what we just also need to do here. And then collinearity of two vectors. So this one is basically, we can also use a dot product, but I think the best thing that we can do here is when we say two vectors are collinear, if it means that if one scalar is a multiple of other, right? So basically, let me say, if this one is 2, then let me say this one will be 4. So like a scalar. So this one, it's good not to use, we are not going to use dot product here. But A, we are going to use dot product because we are talking about projection. This is projection. So we are going to use the dot product to do that because projection goes directly with the dot product. So here, the best option here is the A here. Let's look at question 5. So question 5, we have vector A and B and C, and they are saying that they are coplanar. You want to find X. Okay, so this is very simple here. So all we just need to do is A is the same as 4, 11, and X. B is the same as 7, 2, and 6, and C is the same as 1, 5, and 4. So since they are coplanar, A dot B cross C should be equal to 0. So this will help us to find our X. So let's use scalar triple to do this. So we are going to have 4, 11, X. We are going to have 7, 2, 6. We are going to have 1, 5, 4. This. And then this one will be equal to 0. So we are just finding the determinant. So let's use the top. This is plus minus plus. So I'm going to have 4. Then cancel this and this out. So we are going to have 2, 6, 5, and 4 minus 11. Cancel this and this out. So I'm going to have 7, 6, 1, 4 plus X. Cancel this out. We are going to have 7, 2, 1, 5. This is equal to 0. So let's do the expansion here. This time this will be 8 minus 30 minus 11. This is going to be 7 times 4 is, I think, 28 minus 6 plus K. This is 7 times 5 is 35 minus 2 is equal to, this one is supposed to be X. It's equal to 0. So we are going to have 4 times, this should be minus 22 minus 11. This one too should be minus, no, it should be 22. Then plus, this is going to be X, and this is going to be 33 is equal to 0. So let's just multiply this. This is going to give us minus 8 minus 11 times 22 is going to give us 242 plus 3x is equal to 0. So this is going to give us minus 330 plus 33x is equal to 0. So 33x is equal to 330. Divide through by 33, and we are going to get x to be equal to 10. So x is equal to 10 will be for the value of x to make sure that the equation is equal to 0. So that is coplanar. And let's look at question 6 here. So this is basically simple, but what we just need to know is if I have this divided by y partial of x, this is like you need to integrate this way. So you start from the one here, then you end the here. So we move right to left. So I can write this one as partial with respect to y. This one is the last one, then in bracket partial of x u. So it means that I need to differentiate u partially with respect to x first. So let's do that. We have, let me write to you again here, x squared plus xy plus ex divided by this. So let's do that. Let's go with spread to x first. So 2x plus, this is x. We are differentiating it partially. So we are assuming that this is constant. So with that, we are going to have y minus 1 plus. Now with this one, I want to differentiate with respect to x. So exponential function, I would differentiate what is on the top. So x divided by y. Y is constant. So when I differentiate this, I'm going to have 1 over y. So I'll have 1 over y multiplying e over x over y. So this is what I'm going to get when I differentiate with respect to x. Now let's go with respect to y. Let me push this one here. Now with respect to y, there is no y here, so this is 0 plus. Now there is y here, so this is going to be product rule. When I differentiate y, I'll get 1, so I'm just going to have x y minus 1 plus. Now I maintain y and I differentiate this. Now you see x to the power y minus 1, the one that we are differentiating is up here. So this one is like you differentiating 2 to the power x with respect to x. This is constant base, and then the variable that we are differentiating is up here. So remember that when you want to differentiate this, you maintain the function, then you multiply it by the derivative of the top, which is going to be 1 times length of the base 2. So that's basically what you are going to do here. So since we are differentiating with respect to y, I'm going to maintain the function. I'll multiply it by the derivative of the top. We are dealing with respect to y, so this is going to give us 1 times length of the base, which is x. So I'm going to have length of the base x here. So that is basically what you're going to get when you multiply. So when I do this one, I'm going to have y minus 1 length of x. This is what I'm going to get for differentiating this using the product rule. Then the last one is to differentiate this. This one too, we need to use the product rule. So first, remember 1 over y is the same as y to the power minus 1. So when I differentiate this, I'm going to have minus 1 times y minus 1 minus 1. So this is going to give us minus 2. And this is the same as minus 1 over y squared. So when I maintain this and differentiate this, I'm going to have minus 1 over y squared e to the power y over x over y. So I maintain this and differentiated this. The next one is I'm going to maintain this and differentiate this. So I'm going to have plus 1 over y times exponential function. I maintain the exponential function and differentiate what is on the top, which is x over y. So remember, x over y is the same as x times y to the power minus 1. I'm differentiating with respect to y. So this is like constant. So now differentiate this, which is the same as this, and get this, and multiply it by x. So this one is going to give us minus x over y squared. So I'm going to multiply this one by times minus x over y squared. Now let's try and then simplify to see if it's you the solution. So this plus x y minus 1 ln of x. Then look at the answer here. I think they've combined this one together, right? Good. Okay, I think I missed this one here. This one should be multiplied by y, right? Because we are dealing with the product rule. This one should be multiplied by y. Because if I differentiate first with respect to y, I get this. But now I need to maintain y and differentiate this and get this. So this one should be multiplied by y. So now let's try and then combine this. I have minus here, I can factor it out. I have this one here too, I can factor it out. So I factor this one out. What will be left? It will be left with this times this, which is going to give us 1 divided by y cube, and then plus, because is that right now? This one is not with this one, so this one should be y squared. When I factor this and this out, it will be left with this. Is this rather that it's going to be this times this, and then this one is going to give us x divided by y cube. Don't forget we have factored the minus out already. So when I simplify the one in the parentheses there, I'm going to have this y minus 1 ln of x minus over y. This is going to give us y plus x divided by y cubed. Yes. So this is what I'm going to get from there. So plus minus. So let's check. We need to have something like plus minus. Okay, so we have plus 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 minus minus minus. We have this okay. So let me check it again. So this is minus x to the power y minus. Okay, so it means that c is out, and then the next one is plus y this length. So plus. So since the next one is plus, this one too is out. So we are looking at the plus plus here. So this is y minus this, y minus this, and x, which are all the same. But now let's come and look here. This is supposed to be all plus, minus minus, but I think this is all plus, so it means that the answer is going to be A here. So sometimes when you are choosing the options, you need to be careful from there. If not, you are going to get it to be 0. But, okay, so the question said at 1 and 0, but I think they didn't do that. So here we could have plugged in s is equal to 0 and 1, but I think it's okay to leave it that way. Now let's look at question 7. Let's look at question 7. So question 7, the same thing. Now I want to differentiate this 3 times with respect to x, y, and z. So this is the same as, this is 3 times. So first, when you write one of this, it goes with the x, the second one will go with y, and then the third one will go with z. So this with respect to x, open bracket, this again with respect to y, open bracket, and this will go with the u with respect to z. And then close the bracket again. So what we just need to do first is differentiate u with respect to z. So this is going to give us, so differentiate with respect to z here. This is an exponential function. So u is equal to xyz. This is going to give us, with respect to z, we are going to maintain the function and differentiate what is on the top with respect to z partially. So this will be just xy when I differentiate with respect to y. So this is xy e to the power xyz. Now this is going to give us, now let's differentiate with respect to y, but this one is going to give us a product rule because we have y here and y here. So partial with respect to x, open bracket. First differentiate this y, and we are going to have x e to the power xyz plus, now maintain x, y, and differentiate this with respect to y and have, you are going to have this z times, now you differentiate what is on the top with respect to y and have x z. Let's try and simplify that and see what you are going to get from there. X y z plus, this is going to give us x squared y z e to the power x y z. So now last choice or last step is to differentiate with respect to x. So this is product rule, this is also product rule. So let's go first with respect to the first x, we are going to have this plus, now I maintain the x and differentiate this. So x, maintain this, differentiate the top with respect to x and get y z plus another product rule. Differentiate first with respect to 2 here. You are going to have something like this, 2x y z e to the power x y z, right? And then now plus, now maintain x squared y z and differentiate this. So this is going to give us e to the power yz times, with respect to x is yz. So when I simplify, I can even just plug in without simplifying. So x is 1, y is 1, z is 1. So let's do that. Plug in 1 here, and you're going to get e plus. Plug in 1 here, you are going to get e plus, because this will be 1, 1, 1, 1, 1, 1. So everything will be 1. Plug in 1 here, and you're going to have 2e, because this is 1, 1, 1 multiplied by 2. and this one will be 1. Then plus, plug in 1 here, everything here 1, everything here 1. This one will be 1. We are going to have this. So 1, 2, 3, 4, 5. So this is going to give us 5e as the results here, which is A. So that's question 7. Let's look at question 8. Now, question 8 is saying that we have two functions. Which of the following is correct, right? Okay, so let's try and see. First, let's differentiate f with respect to x. What are we going to get? 3x squared minus 3y squared. Let's differentiate it again with respect to y. We are going to get minus 6xy. Okay. Let's differentiate g with respect to x. What are we going to get? 6x y, right? Good. And let's go with respect to y. This is going to give us 3x squared minus 3y squared. So let's see which relationship holds. This is that when I differentiate with respect to x of f and this one, they are the same. Is this the same as this? No, they are not the same. So A is out. Let's look at B. This is the same as minus of this. No, it's also out. Let's look at C. F of with respect to y is the same as minus of this with respect to x. Yes. So if I negate this one, I get this. So C will be better. But when you look at this one too, it says that this is the same as this, which is not true because it should be the negative of that. So C will be the best option here. Let's look at 9 and 10 together. So we have the parametric equation, right? And we have the position vector here. So we want to find velocity at t is equal to 3. So let's first, we know that velocity is v, which is the r over the t. So let's differentiate this with respect to t, right? So we are going to do it term by term because this is I, this is j, and this is k. So let's do that. I'm going to have differentiate this. This is a length function, length of t. So let's see how we are going to get it. Minus 9 times a length function. If I put this one into parentheses, I'm going to have 1 divided by what is inside the parentheses times, when I differentiate it, what's going to be 1. So I get the first derivative. Then I go in again, I have sine pi t over 3. So when I differentiate sine, I get cos, right? But when I finish, I need to differentiate what is inside with respect to t, which is going to give us pi on 3. So this is going to be pi on 3 cos pi on 3t. Then the last one is 4 plus 2t. So differentiate this one, and what are you going to get? We are going to have 4t3 plus 2. Good. So let's simplify this and have minus 9 over t pi on 3 cos of pi on 3 t, and then 4t cubed plus 2. So we want to look at this at t is equal to 3. Is that right? Yes, indeed. So let's do that. When t is 3, 9 divided by 3 is minus 3, right? Let's plug in 3 here. When I plug in 3 here, 3 will cancel this. So I'm going to have cos pi. What is cos pi? Cos pi is negative 1. So negative 1 times this is going to give us minus pi on 3. Now let's look for t is equal to 3 here. Plug in 3 here. This one is going to be 27. 27 times 4 is going to give us something like 118. I think so. Let me just do 27 times 4. This is 7 times 4 is 8. So I'll have 2 here. This is 8, then plus 2. So this is going to be 110. Good. So we have minus 3, minus pi on 3, and then this one. So you are going to choose A, minus 3, minus pi on 3, and 110. Now the next one is to find the acceleration, right? So acceleration is when we differentiate um, r two times, right? So we differentiate r two times with respect to t, but when you differentiate it for the first time, you get velocity. So we can just differentiate velocity and then we get acceleration, which is a. So let's do that. A will be equal to, now we want to differentiate this function here. So let's try and differentiate this function right here. So let me copy this. Let me copy this one and just paste it here so that we can just this. So I'm going to have this one. I'm going to have minus 9 over t is the same as minus 9t to the power minus 1. Differentiate this and you have 9, because this will multiply this, and I'm going to have t minus 1 minus 1. So this is 9 minus 2, and this is the same as 9 over t squared. So the first component is going to be 9 over t squared. Then differentiate this one again. I'm going to get minus, so when I differentiate cos pi on 3 t, I'm going to have minus sine pi on 3 t. Then I differentiate what is inside, and I'm going to have pi on 3. So when you multiply, you get minus pi on 3 sine pi on 3t. But mind you, we have pi in front. So we are going to have minus pi squared over 9 sine of pi over 3t. Then now differentiate this one with respect to t and have 12t squared. So that's what I'm going to get when we differentiate with respect to t again. Now here too, we are checking at t is equal to 3. So let's do that. 3 squared here will be 9. So the first component will be 1. 3 here, sine pi is 0. So everything here will be 0. So I'm going to have 0 here. Plug in 3 here. 3 times 3 squared is 9. 9 times 12, I think, is going to be 1. Let me check the options, which will help me. 108. Good. So this is going to give us 108. So 10 and 108 is D. 10 and 108. Let's look at question 11. So question 11, we want to look at the unit tangent. So let's do that. So we know that unit tangent is equal to r prime of t divided by the magnitude of r prime of t, which is the same as the velocity and then velocity magnitude. So we have our r here. Let's look for r prime, and then we just do the rest of the work. So r of t is equal to 3 this cos of t, and then we have 6 cos of t, we have 9 sine of t. So let's look for r prime, which is the same as velocity. So r prime of t, which is the same as v, will be equal to, differentiate cos, because this is constant, and get minus sine. When I differentiate what is inside, I get 1. So this is just the same as minus 3 5 sine t. Differentiate cos again, get minus. So minus 6 sine t. Differentiate sine and get cos. So 9 cos t. Good. So this is r prime, which is the same as the velocity. So let's look for the magnitude. So magnitude is going to give us, so pick this one, square it, square this one, and add them. So minus 3 square root of 5 sine all squared plus minus 6 sine t squared plus 9 cos t all squared. So let's simplify. This is the same as, when I square this, I'll get 9. When I square this, I'll get 5. So 9 times 5 should be 45. Then sine squared t. So square this one, get 9. Square this one, get 5. 9 times 5 is 45. Then plus minus 6 squared is 36. Square sine and get sine squared t plus 9 squared is 81 cos of squared t. So this is going to give us, add this to this and get 81. So I'm going to have 81 sine squared t plus 81 cos squared t. So let's see what we are going to get here. I can factor 81 out and have sine squared t cos squared t. But we know that this is going to give us 1. So square root of 81 times 1 is equal to 81, and this is 9. So the magnitude is 9, and we have this one to be this. So it means that we just need to pick this one and divide it by 9 and get our unit tangent. So let me just copy this and just, so my unit tangent is equal to this divided by 9. My r prime divided by 9. So let's see how the solution is look like. So they simplify that. So divide this one by 9 and half, minus square root of 5 divided by 3 sine, divide this one 2 and half, minus 2 sine t divided by 3, and this one is just going to be cos t. So let's see the best option there. Okay, so the best option here is this here. So this is what I'm going to get at the end of the day. So this is the unit tangent. Let's look at question 12. Question 12 is so interesting. Very, very interesting. So we want to find A cross B. Then we cross it with C. But we don't have the component for C. So we just need to use strategies here and the information given, right? So we know A to be equal to 2i plus j. This one is supposed to be j, and then minus 2k. We know B to be equal to I plus j. We know that A dot C is the same as the magnitude of this, and we know that this minus this is equal to square root of 2. So let's start with this. Now we know this property that says that absolute of A squared is the same as A squared, or A squared is the same as this. So what I'm going to do is I'm going to square this. So I'm going to have something like absolute of A minus C minus A squared, and this is the same as C minus A squared. So when I expand this one with absolute, this is going to be C minus A times C minus A. This is the same as C squared minus 2A dot C plus A squared. But we know that A squared and C squared can be written as this. So this absolute of C minus A squared is the same as absolute of C squared, then minus 2A dot C plus absolute of A squared. And then what is this? This is given. This is given as this. So we know that this is 2 square root of 2. So now let's try and look for some of the components and see. So here we can find the magnitude of A because A is already given here. So let's find the magnitude of A here. Magnitude of A is equal to, let's see here, square root of 2 squared plus 1 squared plus minus 2 squared. And this is the same as 4 plus 1 plus 4. This is square root of 9, what is 3. So we got this one to be 3. So this, okay, this one is not supposed to be there. So we are going to square this. So this is 2 square root of 2 squared. Good. This is how it's supposed to be. So this is going to give us 4 times 2, which is equal to magnitude of C squared minus AC, A dot C plus, this is 3 squared. Good. So we need to square it again. Then, now let's do something here. We know that absolute of C is the same as A dot C, right? So this is going to be 8 is equal to A dot C squared minus A dot C plus 9. Let me assume that A dot C is equal to R. So I'm going to have 8 is equal to r squared minus r plus 9. So let's solve for r. So r squared minus r plus 1 is equal to 0, because when I move 8 here, minus 8 will be 1. Then this is, I think this is the same as r minus 1 squared is equal to 0. Yes. Or let me say r minus 1, r minus 1, when you do the factorization here. So it means that r is equal to 1, right? If r is equal to 1, then a dot c is equal to 1. But we know that a dot c is also the same as the magnitude of c. So it also implies that magnitude of c is also equal to 1. So we've gotten this one here. Now, why are we doing this? We are doing this because we need to find this. Good. Now, what do we need to do again here? Now, we know that the angle between A cross B and C is 30. So what we just need to do is, now it means that for us to solve this, then we need to use the cross, way of finding the angle, right? So we are going to have A cross B, is that right? Good. A cross B cross C is equal to magnitude of A cross C, A cross B times magnitude of C sine theta. This is cross, this is not dot, right? Because we are crossing here. We are not doing dot. So this is how we are going to get it, right? But we know that the angle that we are using here is 30 here. So that's basically what you are going to do here, right? Good. That's basically what you are going to do here. And this one, we are going to have it to be magnitude. So this is what you are going to get. So now we know this magnitude of C to be 1. So we can have this one to be A cross B times 1. And then we know that theta is 30. But what is sine 30? Sine 30 is 1 over 2. So this is basically going to be the same as A cross B magnitude times 1 over 2. So now what we just need to look for is, we need to look for A cross B magnitude, right? Okay, there is no magnitude here. So let's do that. Let's first find for A cross B before we find the magnitude. So this is going to give us I, J, K. Now A is giving us this, and B is also giving us this. So we are going to have it to be A first. So we are going to have 2, 1, minus 2, and B is ij. So I'm going to have 1, 1, 0. So I, and this one is going to be cancel this. This will multiply this. This will multiply that. So I'm going to have 0 plus 2 minus j. This cancel this. This times this will be 0, and this is going to be 0 plus 2 again. Is that right? This. Okay. And then this again is going to be 0 again, and then I have this one. Okay. Then this is going to give us plus k. I'm going to have 2 minus 1. So this is going to give me 2i minus 2j plus k, right? So this is what I'm going to get. Now let's find the magnitude of this. So finding the magnitude of this, so finding the magnitude of A cross B is going to give us 2 squared plus minus 2 squared plus 1 squared. So this is 4 plus 4 plus 1, which is 9, and this is going to give us 3. So now the magnitude of this is 3, so we are going to have this to be equal to 3 times half, which is equal to 3 over 2. Now the question is asking us to find the magnitude, right? But since this one is a constant, then when I find this is the same as the magnitude, because this one is not going with ijk, so the magnitude of this is also the same as that, right? So that's basically what we are going to get from here. So we are going to have 3 on 2, which is here. A long way to get the solution. Now let's look at question 13. Find the product rule of these two vectors. Okay, so let's do that. So we want to find A minus B cross, find the cross product, So this is going to give us plus B, and this is the same as this. So let me put this one here, put this one here. So I'm going to distribute this one in half. A cross A plus A cross B minus B cross A minus B cross B. Good. So what did I do? This times this, and this times this will give me this here. Then I pick the B to multiply this, B to multiply this, and have this. But note that with cross, when you cross the same vector, you get 0, right? So when I cross the same vector again here, I'm going to get 0. And then also remember that when I have something like A cross B, under cross, this is the same as minus, because under cross it is not commutative. So this is the same as minus A cross B. So let's do that here. So it means that this will be 0. A cross A is the same as A cross B is the same as A cross B, minus, then we are saying that this here is the same as this. So I'm going to have this one to be minus A cross B, right? Then minus B cross B is 0. So this is going to be A cross B plus A cross B. And this is the same as 2A cross B. So this is what we are going to get from here. And the answer is going to be B here. Let's look at question 14. Question 14, you want to find the unit vector, right? So all we just need to do is, unit vector is the vector divided by its magnitude. So what's the magnitude of this? I think 3 squared plus 4 squared is 9 plus 16. And this is going to give us 25. Square root of 25 is 5. So this is going to give us A, because I divide this one by its magnitude, and that's all. Let's look at 15. 15, we want to find C such that P and this. Okay, let's do that. We want to find the scalars. So now we know that C is minus 2, 3, which is equal to P times this. So P multiplying that, I'm going to have P minus 4P plus Q times this. So this is going to be minus 2Q plus 6Q. So let's group like terms. Here, component by component, I'm going to have P minus 2Q. Then component to component, this is also the same as minus 4P plus 6Q. If you are confused, what I'm doing here is the same as this. C is minus 2I plus 3J, which is the same as P times A is I plus I minus 4J, right? Plus Q times B is minus 2I plus 6J. So you just multiply through by P and you group items I to I, J to J. So this is Pi minus 4Pj minus 2Qi plus 6Qj. Group items and have P minus 2Q or I plus minus 4P plus 6Q or J. Then you compare to the left. So it's the same thing. This one, I can compare this one to this and compare this one to that, which is the same as comparing I to I, J to J also here. So minus 2 is equal to P minus 2Q, one equation. And then 3 will be equal to minus 4P plus 6Q, another equation. So what we just need to do here is solve this one simultaneously to get P and Q. So this is the same as minus 2 plus 2Q. Let's plug this one inside this and have 3 is equal to minus 4 minus 2 plus 2Q plus 6Q. This is 8 minus 8q plus 6q. So this is going to give us 8 will be here, so here will be minus 5, right? Yes, this one will be minus 5, and this one will be minus 2, yeah, minus 2q. So q should be the same as 5 divided by 2. Then let's do that by doing substitution here. So p will be equal to minus 2 plus 2 times 5 on 2, and 2 will cancel 2, so I'll get minus this plus 5, which is equal to 3. So 3 and 5 on 2. 3 and 5 on 2, which is A. 3 and 5 on 2, which is A. Now let's look at the last 4 questions, then we are done. Now we want to find, what are we looking for here? What's the equation of the line passing through this and this? Okay, so remember, this is saying that the word here is, this is parallel, right? So it means that the equation of the line is just straight. It's going to be r of, let's say, t to be equal to c plus bt, right? Because they are already, this one is just the directional vector already. But if this word is not here, then we need to look for cb, vector cb, before we put it here. So let's do that. This is, c is 1 minus 2 minus 1, plus b will be minus 3t, 4t, 2t. Then remember, r of t is also the same as x, y, z. So it means that x will be equal to 1. X will be equal to 1 minus 3t. Y will be equal to minus 2 plus 4t. And z will be equal to minus 1 plus 2t. So x is this, y is this, and z is also this. Let us make t the subject from all the equation to get it in the symmetric form. So this will be x minus 1 is equal to minus 3t. This implies that t is equal to x minus 1 divided by minus 3. Now let's go again. Y plus 2 is equal to 4t. This implies that t is equal to y plus 2 divided by 4. Z plus 1 is equal to 2t. This implies that t is also equal to z plus 1 divided by 2. So we just equate them. X minus 1 divided by minus 3 is equal to y plus 2 divided by 4 plus z plus 1 divided by 2. So let's see which one is the best option for us to choose. Okay, so A is out, B is also out. Is that right? Okay, so the answer is B. Yeah, because it's just like you multiply 2 by minus. This one you want to multiply 2 by minus, so this one will be positive, and this one become minus, and this one positive. This one will change to 1 minus x, which is the same as what is here. Good. Good. So B. Let's look at 17. Find the equation of the plane containing the point x, 1, and r. Find the equation of the plane. Find the equation of the plane. Okay, so I think this is not the options. Yes, this is not the options. I think I made a mistake in the typing here. So the options for this one is basically the one here. So we will come and choose the option from question 18. Let's just do it. This option is for this one. Yeah. So let's do it. We will come and choose the option from there. So here, for us to find the equation of the plane, we know the equation of the plane is x minus x naught plus b, y minus y naught plus c, z minus z naught is equal to 0. So we can pick any of the points to be x naught, y naught. So let me pick this one. So this will be a, x minus 4 plus b, y minus 3 plus c, z plus 1 is equal to 0. So we need a, b, c. A, b, c is the normal vector of I, j, k. So for us to get the normal vector, we need xi cross sr. So I, j, k. So let's look for si, sr, and then we just do that. So what is si here? Si is I minus s. So I minus s. So minus 3 minus 4 is going to give us minus 7. Minus 1 minus 3 is going to give us minus 2. 1 minus 1 is going to give us also minus 2. And let's look for SR, R minus S. So this minus this is going to be positive, so we are going to have 5. Then this minus this will be 0. Then this minus this will be minus 9. So that's what we just need. So we need minus 7, minus 2, minus 2, 5, 0, minus 9. So let's do I. So with I, let me just do it straight. Cancel this and this. This time this will be 18. And then this time this will be 0. So minus 0. Minus j. Cancel this and this. 9 times 7. What are we going to get for 9 times 7? 9 times 7 is, let me see something here. Is this one 9? This is r minus this. Oh, it's this one rather. So I think I made a mistake here. So this one should be 2 minus 4. So it's supposed to be going with x. So 2 minus 4 is minus 2, right? And then 1 minus 3 is also minus 2. And then 8 minus minus 1 will be minus 7. Yeah, I think that's the right thing to do. So this one should be minus 2 minus 2 minus 7. Okay. And then let me check the last one. This one too is IR. So this is going to be something like this. This minus this will be minus 7. This minus this, and this minus this. This one should be 2. Okay. So we are in the same position now. So now let's do the I again. So I will be equal to, now cancel this and this and multiply this one by this. It's going to give us something like this. So this is going to give us, let me cancel this and this. So this time this will be 14. This time this will be, so 14 plus 2, right? Then minus j, this and this will be 49, 7, 49, minus, I just did this times this will be plus 4. Plus k, this cancel this will be 14. So 14 plus 4. So this will be 16 16i minus 53j plus 18k. Good. So that's what we are going to get from here. Now let's try and then plug them in. Am I doing the right thing here? Okay, because the solution is having 18, 58, and 10. So let me just cancel it again. This cancel this. This times this is 14. This times this is supposed to be 4. So this is going to be 18. Let me check this one again. This times this times this is 49. and this will be 4. Good. Cancel this and this. This times this will be 14, and this time this will be 14, 4. Okay, so I think 18. Let me go again. This time this will be 14. Oh, okay, so this one will be minus. Okay, so this is going to give us 10. All right. So now this is the coefficient. So A will be equal to AI plus BJ plus CK. So A is 18, B is minus 53, and C is equal to 10. So let's just do the substitution from here. So I'll just copy this one and then we just finish it out from there. So now we have this one to be this. Our A is 18 times x minus 4 plus minus 53 times y minus 3 plus 10 times z plus 1 is equal to 0. So this is going to give us 18x. Imagine when I multiply 18 by 4, I need to get something like minus 72 minus 53 times y. When I multiply this one by this, plus 159 plus 10z plus 10 is equal to 0. So 18x minus 53y plus 10z. Then let's combine this, this, and that. When I add this one to this, I'm going to have 169 minus 72. This is going to give us 7. And then this is going to give us 9. So plus 97 is equal to 0. So anyone with plus 97. Okay, so I think I was trying to change this question here and then I don't know what happened. So 18, 53, 10, and then this one. So the answer is supposed to be C here. Supposed to be B here. So this is the solution for the 17, right? Good. So let's look at the 18 here. So the 18, the option 2 is gone, but let's solve it and get the answer here. So now here we want to find the area of a parallelogram, which we know that this should be A dot B cross C when you find the magnitude. So let's just do it quick. So A dot B cross C is equal to 2 minus 3, 1, 1 minus 1, 2, 1, 2, 3. So we are using this here as one, ABC. So let's do that and see what we are going to get from here. So we are going to have, what are you looking for? The question again? Oh, okay. So this one is not the one that I was thinking about. This one should be AB cross AC, rather, sorry. So this is equal to IJK. So let's look for A. AB will be equal to B minus A. So what are you going to get? B minus A. So 1 minus 2 is going to be minus 1. Minus 1 minus minus this is going to be 2. And then 2 minus this is going to be 1. AC is the same as C minus A. So C, 1 minus this is going to be minus 1. 2 minus 3 is going to be 5. 2 minus minus 3 is going to be 5. And then 3 minus this one is going to be 2. So minus 1, 2, 1, minus 1, 5, and 2. So let's plug them in. This will be minus 1, 2, 1, minus 1, 5, and 2. So now let's see what we are going to get from here. Now this is going to give us I. Cancel this and this. 4, 5. So 4 minus 5. Minus J. Cancel this and this. Minus 2 plus 1. Minus 2 plus 1. Plus K. This and this. Minus 5 plus 2. Good. So this is going to be minus I plus j minus 3k. So now we want to find the magnitude. So now that we need to find the magnitude. So magnitude of this is minus 1 squared plus 1 squared plus minus 3 squared. And this is 1 plus 1 plus 9, which is equal to square root of 11. So the options, we had square root of 11 in the option. So I think the answer was supposed to be B from there. So you can check your quiz question and you see that I just interchanged some things there here. Let's look at the last two questions and then we are done here. The last two questions. So here we want to find the point P where this line intercept this line. So this is very simple. So what we just need to do is we need to look for T, right? And come and plug it inside this to get the intersection point. So what we are going to do is, since they are intercepting, I'm going to plug this one inside this inside here, this inside here, and find for T. So 3 times 8 on 3 plus 2T plus 2 minus 2T plus 6 times 1 plus T is equal to 6. So I just do the substitution there and then there's find for T. So this one will be 8 plus, because this will cancel this, plus 6T plus minus 4T plus 6 plus 6T is equal to 6. So I have T here, I have T here, I have T here. So this is going to give me, I think, 8T, and then it's equal to 6 minus 6 minus 8. So this is going to give us 8T is equal to minus this, and T is equal to minus 1. Is that right? Yes. So let's just do substitution here. Plug in T is equal to 1 and get Z to be equal to, is that 1? Minus 1. And get Z to be 0. Plug in minus 1 here and get it to be 2. Plug in minus 1 here and have X is equal to this minus 2. So let's try and simplify this. 8 minus 6 and get 2 on 3. So 2 on 3, 2, 0 is right here. So this is what I'm going to get for the P point. Let's do the last question and then we are done here. Last question. So the last question is asking us to find the equation of the plane and containing this and then intersection at this. So here is ax minus x naught plus bx y minus y naught plus c z minus z naught is equal to 0. Now note that intersection right here. So this is our x naught, y naught, z naught. So we are going to have ax minus 1 plus b y plus 1 plus c z minus 2. So we just need to look for a, b, c, then we are done. Now for us to get a, b, c, we need the directional vectors from this. So don't forget this here is just like divided by 1. Directional vectors are the one here, right? The one with the t. Remember here we are making t the subject. So when I multiply this one by t, when I multiply this one by t, this one by t, with this one by t. So that's basically what is happening here. So d1, what is the directional vector? I can say I have 1, 2, 2. D2, I can say that I have 2, 4, 3. So these are my directional vectors. So I need to find the normal vector so that I can get A, B, C. So this is I, J, K. I have 1, 2, 2, 2, 4, 3. So now let's try and dot it and see what we are going to get. I, cancel this and this. 6 minus 8. 6 minus 8 minus J, cancel this and this. 3 minus 4, so I have 3 minus 4 plus K, cancel this and this. 4 minus 4, so 4 minus 4. So I'm going to have minus 2I plus J, K will be 0, so that place goes to 0. Now let's try and do substitution here. So from here, what are we going to get? We are going to have our equation to be minus 2, because here is a is minus 2, b is 1, and c is equal to 0. Minus 1, right? And then b is 1, so plus 1 x y plus 1. But c is 0, so this component will just go to 0. So I will just equate this one to 0. Minus 2x plus 2 plus y plus 1 is equal to 0. Now let's look at how the answer is being written. Okay, so this is the same as minus 2x plus y plus 3 is equal to 0. Do we have any option like that there? Let's move it up there and go and check it out. Okay, so we don't have any option with minus 2 this and that, but we can multiply through. This one is like a scalar, right? So we can multiply through by, let me say, 5. When I multiply through by 5, this one will be 10, 5, 15. Or we can divide through by 5 in any of them and see. So this, we need minus. Okay, so minus. So it means that it's better for us to divide through by minus 5. Multiply through by minus 5. So this will be 10x minus 5y plus minus 15 is equal to 0. So any of that here is going to give us c here. Good. So this one is also the same as dividing this one through by minus 5, and you're going to get this one here. So you need to pay attention to this kind of questions with the scalar and those kind of things. So this is the end of the video, and I wish you all the best in your final exams. And I think right now we can write Math 102 with confidence. So